Well, good morning or good afternoon, depending on when you're doing this lesson. So there's a couple of things that I need you to do, and one thing is to get yourself some paper to write on and get yourself a pen to write with so that we can carry on with the lesson. If you haven't got those things, go and get them now. Okay, so the next thing that we need to do is to make sure that you are distraction free. So make sure your phone is turned off and it's a little bit further away from you. I don't want you to be sending text messages as you're going through this lesson. I also want you to make sure that the television's turned off, that you're not Xboxing or PlayStationing whilst you're doing this lesson, because I need you to concentrate for the next 45 minutes. If those things are around, go and turn the television off now. Go and make sure that you're not going to be distracted. Okay, fantastic. Let's start the lesson. Okay, so this is our spaced retrieval. You know how to follow these. So all I want you to do is to give yourself about 5 minutes. The timer's not going to work, but give yourself about 5 minutes, and on your piece of paper you're going to put question 1 and then tell me how you work out an average. Question 2, just give me the answers. Just put the answer to 1 down is, and 2 and 3 and what the answers are. If you want to copy the crossword out, you can, but at this point there's no need. And then question 3 is for you to write 5 facts about the picture that you can see. Okay, so off you go and do this. Once you've finished, move on to the next slide. Okay, so get yourself a green pen and you can mark your answers. Make sure you do use the green pen, because that's going to show you where you might need to revise in future. Okay, so please self-assess your work. Once you've done that, move on to the next slide. So I have set you some homework, so Merry Christmas for the homework. It's called Common Tests. So if you check on Go for Schools, I've got a link to a Microsoft quiz for you. I know most of Year 9 are using Educate, but I've written these tests specifically for you and specifically for what we are studying here. So if you can go and do those Microsoft quizzes, you will find the link in our Microsoft Teams. But if you go into Go for Schools, the link will be there that will take you to that assessment. So if you haven't had a go at them, then go and try them, and I'll be able to see and I'll give you some feedback. Okay, so what we're going to do in this lesson today is to look at how acids react with carbonate compounds. So we're going to look at acids and base reactions. Carbonate is a base. We're going to recall some of the names of the products, and we're going to write some word equations. We're going to look at how to test for carbon dioxide, and that is going to be something when we get back into school and I can organise some experiments for us. We're going to be doing these. In fact, we've got quite a lot of experiments to do. And also I want you to be using those keywords. I want you to be talking like a scientist and to use those scientific keywords to make your writing more scientific. Okay, so on the next slide there is a YouTube clip. So once you go on to the next slide, let the YouTube clip load and then press play, and it's all about reactions of metal carbonates. So listen through the video, and then I've got some questions at the end for you to start doing.
In this video, we will explore the reaction between acids and metal carbonates. Recall that an acid is a chemical that contains a special type of hydrogen that can be released into aqueous solution as a hydrogen ion, H positive. The most commonly used acids in the laboratory tend to be hydrochloric, sulfuric, and nitric. It's the release of positively charged hydrogen ions and not the presence of the negatively charged counter ion, chloride, sulfate, and nitrate, which confers the properties of an acid. One very quick chemical test for an acid is to add a little metal carbonate to it, such as calcium carbonate, or CaCO3. The evolution of bubbles of carbon dioxide are evidence that an acid was used. Geologists often dribble a little acid over an unknown rock sample. If fizzing is seen, then the rock is a carbonate. In neutralization, you might recall the general equation: acid plus base equals salt plus water only. Most metal carbonates are almost insoluble in water, but will react with an acid, and so are regarded as a base. Acid plus metal carbonate equals salt plus water plus carbon dioxide only. Rainwater is a natural acid due to dissolved carbon dioxide. This is the weak acid called carbonic acid, which at higher concentration gives sparkling drinks their sour taste. When rainwater meets calcium carbonate, either in rocks or as part of buildings, there is a chemical reaction. This turns what is essentially an insoluble rock into a soluble material, which gets washed away. This is what creates underground caverns in limestone areas, and why acid rain slowly wears away historic buildings. To confirm that the gas made is carbon dioxide, we can use this simple setup to pass it through lime water, a solution of calcium hydroxide. After a few seconds, a white milkiness is seen, which is microscopic specks of insoluble calcium carbonate being made in the reaction. Don't let the gas bubble for too long, as the reaction will make carbonic acid, which reacts with the insoluble calcium carbonate to make soluble calcium hydrogen carbonate, as shown before, leading to a clear solution.
If you liked the video, give it a thumbs up, and don't forget to subscribe. Comment below if you have any questions. Why not check out our FuseSchool app as well? Until next time.
Okay, so having listened to the video, I want you to match up the words on the left hand side in the black boxes with the formula of their ion. Okay, so you can either copy the boxes as they are on this PowerPoint, or you can write sodium ion and then write what its ion is. So you can either write the boxes out and then do the proper matchup, or you can just write the correct word formula next to the word. Once you've done that, put a big circle around which ion makes acids acidic. Did you listen to that video? If you're not sure, you can go back and listen to the video again. But which ion is it that makes acids acidic? All right, you've got a few minutes to do that now. Once you've done that, you can move on to the next slide with your green pen and you can see if you're right. Okay, so give yourself 5 minutes to do this and then move on to the next slide. Okay, did you get them right? Did you spot that the hydrogen ion was H+, and that's the ion that makes acids acidic? Did you spot the sodium ion, Na? Use your periodic table to work out what that formula is. So Na+ is the sodium ion, and chloride ion, Cl-, that leaves hydroxide ion as OH, and that's what makes alkalis alkaline, OH-. So H+ makes acids acidic, and I've highlighted them there. Okay, so how do we test for an acid? How do we know what's in that beaker? So how do I know this is an acid? Says the student. Well, you can add a metal carbonate to it. It'll fizz. So if we add a metal carbonate, we should see fizzing if it's an acid. So that's how we can test for an acid, adding a known metal carbonate. Okay, so geologists use the idea that acids react with carbonates, and if they want to test some rocks to see if they contain carbonate compounds, they add acid to them. So where do they find these rocks? Well, here's a picture of the UK, and first of all, Hunstanton Beach in Norfolk. Norfolk is, you can see where the arrow is pointing to this purple area here in Norfolk. This is Hunstanton Beach, and you can see this white band of limestone, calcium carbonate. So we have it in Britain. And Hunstanton, this is about an hour and a half, 2 hours away from where we live in Nottingham. We're not that far away from the beach really, and Nottingham's in the middle of this red section here in the middle of the UK. Cheddar Gorge in Somerset, and as you can see it's pointing to the left hand side of the UK, so Somerset is just before you get to Devon, and Cornwall's a very popular holiday area, but Cheddar Gorge is gorgeous, absolutely lovely, and it's got these beautiful rocks and this scenery is fantastic, but it's made of limestone. And so the geologists are able to test it, and they can say, yes, it's made of carbonates. And not far from where we live, in the Peak District, or just on the edge of the Peak District in Derbyshire, you can see this map here, and you can see Nottingham, and then to the left, diagonal left, top left, is Longcliffe Quarry, and that is only 58 minutes away from our school. So if you were to drive there, it's 58 minutes, and there's a lot of limestone in the hills. And this is Longcliffe Quarry. You can see they have taken out that limestone, that calcium carbonate, and it's sold. So it's used in buildings and in road manufacture and lots of areas. But geologists can tell it's a carbonate, or in this case calcium carbonate, by getting some of the rock and by adding acid to it. And can you see on the rock where the acid is, it's starting to bubble. So what we've got here is the rock that's being tested. It's got a red arrow on it. This is a pipette, and it's got some acid in, maybe hydrochloric acid or sulfuric acid. And you can see it's been dropped on the rock, and the fizzing shows that a gas is produced. So that fizzing is gas coming through the liquid, and the rock is made from carbonate compounds. So we know because of the fizzing it has to be made of carbonate compounds. Okay, so what I want you to do here is to draw yourself a rock and draw the pipette and the acid coming out of it, and I want you to label it. I want you to complete the rock testing, the testing rocks picture. So how do you test rocks for carbonate? And see if you can put all the labels in that were on the previous slide. Okay, so draw the rock, draw the pipette, and then label it. Don't forget to put the fizzing in as well. You can pause here, and once you've done your picture you can move on. Okay, did you get it right? Have you got your green pen? Let's go through. So you should have pointed to the rock for testing. If you haven't, add that into your picture. You should have pointed to the pipette and said this was the pipette and acid. Just check your spelling. If spelling's not right, make sure it is right. P-I-P-E-T-T-E. Make sure you spell that right. And then we can see the gas that's coming out, the fizzing that the gas produces. So you need to be able to label that. Again, put it in if you've missed it. It's okay at this stage. And this just shows that the rock is made from carbonate compounds. Okay, so take your time, make sure you correct your work, and then we can move on to the next slide. Okay, so what is a carbonate? I keep talking about carbonates, and I want to make it fairly clear what they are. So they're like a family of compounds, the carbonate compounds, and just like any family, they have a family name or surname or last name. So like Smith, or in my case Oates, or Anto, like Mr. Anto, Hussein, or Rashid, or Chang, or whatever your family name is. You know, that is the family of compounds. It has the family name, and like any family, we can distinguish between the carbonates by their first name. So in my family, my sister's called Janet, my brother's called Peter, I'm called Karen. So my mum and dad can tell us apart. Well, it's the same with the carbonates. So like people have different, in different families have different names. It could be Tom or Aisha or Raj, Harry, Jan. It's a different name. So it could be, I'm Karen Oates, my sister's Janet Oates, my brother's Peter Oates. It could be Tom Smith, Daisy Smith, and Floella Smith. So it's be able to tell them apart. So let's look at some examples on the next slide. Okay, so let's meet some of the carbonates. Well, here's our first one, copper carbonate. Okay, so this is made from copper and carbonate, so copper carbonate. Our next one, sodium carbonate. It's made from sodium and carbonate, so this is a compound, sodium carbonate. Magnesium carbonate is made from magnesium and carbonate. We've also got cobalt carbonate. Beautiful pink colour, I quite like this one. So cobalt carbonate made from cobalt and carbonate. And then iron carbonate. Again, this is more rock-like, but a lovely colour. So iron carbonate made from iron and carbonate. And then finally calcium carbonate, and that's limestone. We know that as limestone. So it's made from calcium that we would find in our bones, and carbonate. And this is the white rocks that we see in the cliffs that can be used to make statues and buildings. So there are many, many different carbonates. Okay, so let's look at how we can recognise and where the name metal carbonate from. So metal is the first name, so it could be any metal, and I told you about copper carbonate, magnesium carbonate, so the metal could be any one of the metals in the periodic table. And carbonate comes from two elements, carbon, and the 8 is a different element. So here we go, metal, any metal in the periodic table could be a carbonate. Carbon is from carbon, and the 8 means many oxygens, or contains several oxygens or some oxygens. So this is a compound that contains a metal, carbon, and some oxygens. So carbonate means carbon with some oxygens. Okay, so we're at a stage where I want you to do a little bit of matching up. Now, again, you could copy this slide down into your book, or you could number the left-hand side and put a letter on the right-hand side. So let's have a look. How do we recognise carbonates? Well, the metal could be anything from the periodic table, and I've picked magnesium, which is Mg, copper, which is Cu, and calcium, which is Ca. Now, carbonate, I told you, was made from carbon and some oxygens, and it's made from carbon and 3 oxygens. That's what the little 3 stands for. So here I've got magnesium carbonate, copper carbonate and calcium carbonate. So you can write those three names in your book, and what I want you to do is to write the formula opposite it: calcium carbonate, CaCO3, MgCO3, CuCO3. I want you to match up that formula with the name, and you can either write the formula next to the correct name or just write it as it is and do some lines to match it up with lines. Okay, once you've completed that, you will need to do this next one. So using your periodic table, you will need to find the chemical symbols for the following. Now we know carbonate is CO3, but you'll need to find the symbols for the metals. If you don't have a periodic table with you in your book, if you didn't take your books home, then look online. Look for a periodic table online. There are plenty. Just put in Google search periodic table. Okay, and you've got these 4 compounds to write the formula for. Okay, once you've done that, you can move on to the next slide, but don't move on until you've completed this. Off you go. Okay, so how did you do? Which one was magnesium carbonate? Yes, it was the middle one. Which one was copper carbonate? Well, copper is Cu, so we can match the name with the bottom formula, and that leaves calcium carbonate, CaCO3, as the top one. Okay, so if you've got all of those right, fantastic. Okay, so how did you do with the formula? So iron is Fe and carbonate is CO3. So the formula FeCO3. Beryllium, Be, carbonate, CO3. So you should have got BeCO3. And then zinc carbonate, Zn, CO3. And barium carbonate, barium is Ba and CO3. Okay, so make sure you've got those ticked. If you've got them wrong, then write in the correct answer with your green pen. Off you go. Okay, so here's an extension question. If group 1 metals have the formula N2CO3 and M's the metal, lithium carbonate would be Li2CO3. Use your periodic table. What's the formula for sodium carbonate? Okay, you can go and do that now. Once you've got the answer to that, you can look at the slide on the next slide. The answer's there. No sneaky peeking. Off you go and answer this extension question. So did you get it right? Did you find that sodium was Na? And because it's in the same group as lithium, group 1, it's Na2CO3. Okay, if you didn't, make sure you use your green pen and write it in now. Okay, so let's have a look at some reactions of metal carbonates with acids. So metal carbonates do react with acid and they'll form a colourless gas. We see that as a fizz. The gas is given off and we see fizzing, and that colourless gas is carbon dioxide. It also forms water and the metal salt. So it does depend on what the metal carbonate is as to what the metal salt is. I'll give you an example later in a minute or two. So the metal salts do depend on the acid you use as well. So for instance, hydrochloric acid forms metal chloride salts. So hydrochloric acid will give chlorides. Sulfuric acid will form metal sulfates. So sulfuric acid is sulfates, and with our carbonate we'll create a metal carbonate. So here we can see a particle diagram we can see magnesium and carbon and 3 oxygens, so that's our magnesium carbonate. And I'm going to react it with sulfuric acid. You can see sulfuric acid here. It's 2 hydrogens and this SO4 group. I've just simplified that. And when the acid reacts with metal carbonates, it's the hydrogen ions that come from that acid that start the reaction. And so we can see here that we're going to create a salt, magnesium sulfate. So that's the sulfate part of sulfuric acid will go with the metal, the magnesium. The carbon and 2 oxygens will come away from the metal carbonate, and that will give us carbon dioxide. And then the 2 hydrogens will combine with the final oxygen, and that gives us H2O, water. So above at the top you can see metal carbonate reacting with sulfuric acid. At the bottom you can see that those atoms have rearranged themselves, and we've got magnesium sulfate, carbon dioxide and water. So they're the products of the reaction. Let's have a look at that again, but with hydrochloric acid. That'll be our next one. Okay, so here we've got magnesium carbonate again, the Mg, the carbon, C, and the 3 oxygens make magnesium carbonate, and that's going to react with hydrochloric acid. And you can see here hydrochloric acid is an H and a Cl, a hydrogen ion and a chloride ion. And I've had to use 2 hydrochloric acid molecules, and you'll see why. So the magnesium reacts with the magnesium carbonate reacts with the acid, and our product is a salt. It's magnesium chloride. And then the carbon and oxygen come away to give us carbon dioxide. That's the colourless gas. And then the 2 hydrogens will combine with the oxygen that's on its own, and it gives us water. So you can see at the top, magnesium carbonate reacts with hydrochloric acid, the HCl, and our products are magnesium chloride, the Mg and the 2 chloride ions, carbon dioxide, the C and the 2 O's, and water, the oxygen and the 2 hydrogens. So they are our products. So the salt, carbon dioxide and water. So carbonate plus acid will give us a salt, carbon dioxide and water. Okay, so task 4 is for you to copy those particle diagrams of magnesium carbonate and sulfuric acid and magnesium carbonate and hydrochloric acid. Just copy those particle diagrams and show me what the products are as a particle diagram. So show me the particles of magnesium reacting or being next to the sulfate and the carbon dioxide and the water. Okay, and then the same with the chloride, the magnesiums with the chlorides, the carbon dioxide and the water, but show them as particle diagrams just as they are there. Okay, you can have about 5-6 minutes to do that for me. That would be fantastic. So off you go. You can check on the next slide whether you did it right or not. Okay, so let's see if you got it right. So with magnesium carbonate and sulfuric acid, you would have got magnesium sulfate, carbon dioxide and water. Do your particle diagrams look like that? If not, then use your green pen and correct them. Then magnesium carbonate with hydrochloric acid, we've got magnesium chloride, carbon dioxide and water. Again, check that you have those particle diagrams. Okay, so I was going to use this slide to ask you to tell me the product. So if copper carbonate reacts with hydrochloric acid, what are the products? Okay, so I'm going to spin the wheel and Cameron is going to tell us the answer. So what is the answer? Copper carbonate reacting with hydrochloric acid. What will get? We will, if you know, shout out the answer. Okay, we're going to get copper chloride, carbon dioxide, and water. Okay, let's do the next one. So see if you can answer before the person it chooses. So cobalt carbonate reacting with hydrochloric acid. Okay, what are the products? Who knows the answer? That is going to be Connor. Okay, so can Connor tell us the answer? So the answer is, remember here's the metal, so it's going to be cobalt chloride, carbon dioxide and water. That's correct. Okay, let's have a look at another one. Okay, so sodium carbonate, that's going to react with sulfuric acid. So what is the salt now? What is it going to give us? Let's see who can answer. Oh, it's Connor again. Connor, can you give us the answer? Sodium carbonate reacts with sulfuric acid. What's the salt? It's going to start with sodium and it's going to have sulf in it. Okay, sodium sulfate, carbon dioxide and water. Let's look at another one. So iron carbonate, we're going to react iron carbonate with sulfuric acid. So what are we going to get? What are the products? Okay, let me see again. What's the salt going to be? Gittis. Gittis going to answer for us. So what's the salt? It's going to be the metal and then the acid name. So it's going to be iron sulfate and the rest is carbon dioxide and water. So iron sulfate, carbon dioxide and water. I think we might be getting this. Let's have a look at the next one. Okay, so magnesium carbonate. I'm going to react magnesium carbonate with, I'm not going to react it with that, sulfuric acid. Magnesium carbonate with sulfuric acid. So what is the product going to be? Let's see if we can get someone different. Rashid. So what's the answer going to be? There's the metal, look, magnesium, and it's got something to do with sulfuric acid. So the salt is magnesium sulfate and carbon dioxide and water. Okay, so I'm sure we could all answer this question together, but I'll spin the wheel anyway. What does calcium carbonate reacting with hydrochloric acid give? And it's Rashid again. Shall we spin that a second time? Okay, diamond. So what's the answer? There's the acid, look, hydrochloric, and the metal is calcium. So what are we going to get? We're going to get calcium chloride, carbon dioxide and water. Absolutely. Okay, let's see, let's move on. Okay, so on the next slide, we're going to look at how to test for carbon dioxide. So I need you to keep focusing on this and to concentrate really hard because it's really important that you're able to describe how to test for carbon dioxide, what are the reagents that you're going to use, and to be able to tell that back to me. This is only a very short video, so once you put the slide on, wait for the YouTube to attach to the internet, and then you should be able to watch this on the slide.
Experiment of detecting carbon dioxide gas using clear lime water. Calcium hydroxide, which is known as clear lime water, is used to detect the presence of carbon dioxide gas dioxide gas for a longer time, the precipitate disappears, since insoluble calcium carbonate changes into soluble calcium bicarbonate.
Okay, so here I've got a test tube that's got lime water in it. The first test tube is clear and colourless because it hasn't got any carbon dioxide in there. I'm going to bubble carbon dioxide through that lime water, and you can see in the middle picture it's starting to go this cloudy milky colour, and that shows us that we've got some calcium carbonate coming out of solution. That shows me that the carbon dioxide is reacting and we're seeing this white colour. In the final test tube on the right hand side, we can see that the lime water is now cloudy. It's a cloudy milky white, and the cloudiness is very fine particles of solid, and we call that a precipitate. So what colour changes do you see? You see it going from clear and colourless to cloudy and milky white. And in your booklets I did ask you to complete a picture that I put in there, but if you could do that now for me, that would be fantastic. Okay, so here's another way of testing for carbon dioxide. So if you're not able to bubble the carbon dioxide through lime water, what you can do, as the first picture shows here, is you can collect the carbon dioxide with a pipette by drawing in the gas into the pipette from the liquid. So that's what the first picture shows, taken in the gas, not the liquid. And then you're going to carry it over to a second test tube, and the second test tube's got lime water in it, and you're going to squeeze your pipette and it's going to bubble the gas through the test tube, and that will create, we hope, if it reacts, a milky white colour. We should see the changing colour. So that's another way of testing. So if you've not got very much gas, or you're not able to bubble it through lime water, you can collect it in a test tube and bubble it yourself. Now I want you to remember this because it's one of the questions I'm going to ask at the end that you need to look at. Okay, so I'm not sure that the timer is going to start, but I want you to look at these three pictures. Which picture shows the correct test for carbon dioxide? Is it number 1? Is it number 2? Or is it number 3? Okay, which picture shows the correct test for carbon dioxide? Write it on your book now. And it's number 1. Okay, so you can see that the gas is being bubbled through a test tube. So that is testing for carbon dioxide. Right, are you ready for check number 2? So when copper carbonate reacts with hydrochloric acid, which is the wrong product? Okay, so you need to know what the right product is, but which one of those is the wrong product? Okay, so you need to vote now. Which one is it? 1, 2, 3, or 4? Okay, let's have a look. It is hydrogen. Hydrogen's the wrong product. So copper carbonate will give us copper chloride. We'll get carbon dioxide and we'll get water, so we won't get hydrogen. So that's the wrong product. Okay, well done. Okay, so I've got 5 pictures here that I want you to look at, and in your book write 1, 2, 3, 4 and 5 and answer the questions. So for number 1, have a look at the picture. What happens to the lime water when you bubble your breath through the lime water? Write your answer now. Number 2, what happens to the lime water when you add, if you look at the picture, dilute hydrochloric acid to potassium carbonate. What are you bubbling through it? What's going to happen to the lime water? Does it change colour? If it does, what does it change from and to? Okay, look at number 3. What gas is given off? Well, sorry, what gas does the yeast give off? Can you have a look at the picture? What's happening? What are they bubbling the gas through? On the left-hand side is our glucose and yeast, but on the right-hand side, what are they bubbling the gas through? What will it show if it turns milky? What are they testing for? What gas? Okay, and number 4, if we have a look at that picture, describe how you would test the gas jar for carbon dioxide. There's carbon dioxide in there, but how are you going to test it? How are you going to collect that gas and test it? Remember, I said earlier on in the lesson, you'd need to remember this technique. And number 5, look at the picture. Something is wrong. Help! Something is wrong with this picture. This student's trying to test for carbon dioxide, but she can't. Why can't she? What is wrong? Have a look at the diagram. There must be something badly labelled or wrongly labelled. Can you correct the label? What should it say instead? Okay, I'd like you to have a go at this 2-mark exam style question. So you can see the answer, the questions A and B here, so you can write those in your book. But we're looking at a student investigating metal carbonates. You can see in the diagram that the metal carbonate is being heated, and whatever is being given off is being bubbled through a solution A. The student's results are in that table. You can see the metal carbonate is on the left-hand side. I think I'll just get my laser pointer. So here you can see the metal carbonate is copper, potassium and zinc. The colour before it was tested was green or white for potassium carbonate, white for zinc. The colour afterwards was black or white, so they're all being heated. This is the mass before and afterwards, and you can see that there's a mass loss between the on the copper carbonate one and on the zinc carbonate, but not the potassium. Solution A, this solution A here for copper carbonate, it turns cloudy. What does that tell you it's giving off? Potassium carbonate, it stays colourless, it doesn't change. And the zinc carbonate, it turns cloudy. What is that telling you it's given off? So it says, use the correct answer from the box to complete the sentence. The colour of copper oxide is it black, green or white? Well, copper carbonate is here, and this is the colour of the copper carbonate. What colour is copper oxide? Have a look on there. Which colour matches it? And then solution A is used to test for carbon dioxide. Carbon dioxide turns solution A cloudy. The name of solution A. Now it's not in here. You have to remember what it is. So can you remember? You need to write that in. Okay. Off you go. Okay, so you've got 3 things to remember. What can you remember? Describe the test for an acid, and I've put a little picture there to help you. What is the test for an acid? describe the test for a carbonate, and I've put a picture there of a rock so you can tell me what the test for the carbonate is, and then describe the test for carbon dioxide, and again I've given you a picture for you to have a go. Alright, so write your answers now.